April 2026. At Google Cloud Next in Las Vegas, the tech industry gathered under the weight of significant enterprise AI expectations. CEO Thomas Kurian took the stage to announce the Gemini Enterprise Agent Platform, positioning it as the successor to the established Vertex AI environment. But the architecture of this platform revealed a striking contradiction. Google chose to natively integrate over 200 models, including Anthropic's Claude series, alongside its own Gemini lineup. Tech giants rarely host rival products on flagship infrastructure. By absorbing Claude into their ecosystem, Google acknowledged that performance advantages between leading models are temporary and increasingly difficult to maintain. The underlying neural networks have reached a state of commoditization. The ability to generate text or code is no longer a viable competitive moat for these companies. The projected valuations of these platforms now depend on the system that governs the model. The strategic differentiator has shifted to the software layer that coordinates and directs those outputs into a business workflow. Until recently, AI interaction was defined by a single prompt, yielding a single response. It was a tool waiting for a human trigger. As the bottom layer shrinks into a utility, a broad, intricate layer expands above it, the agent orchestration layer. Google built this stack around three components: an agent development kit, a memory bank, and an agent runtime for execution. Together, these allow an algorithm to maintain a state, decompose a complex objective into smaller tasks, and execute multiple steps over a prolonged period without waiting for human intervention. This transitions AI from a passive generator into an active, stateful, pseudo-business entity. Engineering an autonomous loop inside a cloud sandbox is a technical achievement. But plugging that non-deterministic entity into the strictly audited rules of global enterprise systems triggers a sharp architectural clash. As these agents begin performing actual work, the immediate engineering challenge is interoperability. The market requires that workflows move smoothly between different corporate environments. The industry solution relies on protocols like Anthropic's Model Context Protocol and the emerging agent-to-agent, or A2A, standards. These frameworks allow a Google agent to delegate tasks to a Microsoft agent. They can communicate and pass outputs back and forth without exposing their internal reasoning to the other platform. These open connections suggest a decline in vendor lock-in, as agents move freely between competitive ecosystems. However, an agent's reasoning capability depends on access to specific corporate histories, workspace documents, ERP transactions, and CRM profiles, which remain physically tied to their parent platforms. The performance of the AI is bottlenecked by its access to this specific, non-replicable context. While the connection protocols are open, the enterprise value remains bound by the structural weight of proprietary data. This tension explains why 77% of enterprise AI usage happens in external applications, disconnected from core financial systems. To understand why, we have to look at the environment where global transactions settle: SAP S/4HANA. S/4HANA operates on the principle of the logical unit of work. Before financial data is committed to the database, the transaction must be consistent across every parameter. This creates a physical incompatibility. On one side, the AI agent is fluid, operating on statistical probabilities. On the other, the ERP is built on rigid commits and strict audit trails. An agent's speculative reasoning cannot survive a system requiring absolute determinism. In domains governed by compliance, like IFRS 15 for revenue recognition, an algorithm cannot dynamically alter a decision path. The accounting rules are inflexible. A non-deterministic, probabilistic actor cannot have direct write access to a heavily audited financial ledger. To deploy agents in this environment, their autonomy must be restricted. System architects resolve this by splitting the workflow in two: a proposal phase and an execution phase. The agent is restricted to the proposal phase. Its tasks are limited to pre-processing. It reads unstructured contracts, extracts fulfillment obligations, and flags exceptions like variable pricing. After processing, it does not commit the action. It generates a draft. A boundary separates the draft from the ledger. The agent's output must pass through a human or deterministic approval gate before the database is modified. This solves the compliance problem. Auditors don't require a transcript of the neural network's internal processing. They must trace the data the agent referenced and the rules applied at the approval gate. In the enterprise, agents are not autonomous executors. They are proposal generators, relying on human or deterministic triggers to act. Because of this friction, agent integration will not lead to immediate headcount reductions. Deploying agents drives a sharp increase in labor. Every operational process must be deconstructed to define exactly which data streams inform which decision branches. Traditional corporate silos, where business units, IT, and security teams operate in isolation, are ill-equipped for this integration. You cannot map an AI process if the logic is compartmentalized. This demands a new discipline, the orchestration architect. This role bridges the probabilistic output of an AI with the rigid governance of enterprise databases. The talent bottleneck has moved past writing prompts. It is now defined by the ability to map and secure decision boundaries. This bifurcated architecture, where AI proposes and humans execute, creates a psychological vulnerability. When an agent consistently generates highly complex proposals, human operators naturally stop scrutinizing the work. Managers end up mindlessly clicking approve, effectively validating logic they no longer comprehend. If the human in the loop becomes an administrative formality, the responsibility for the decision is systemically compromised. Ultimately, the enterprise absorbs cumulative, untraceable risk. As this technology matures, commercial superiority will not belong to the firm with the largest AI model. Dominance belongs to the platforms that can engineer the most transparent and auditable boundary between probabilistic reasoning and deterministic enterprise execution.